Hey guys, nice to have you here. Now, in this lecture, we are going to look at the Lemieux reagents and subsequently oxidation of aromatic ring. And this will be lecture 7 of our lecture series. Now, let us look at what the Lemieux reagent is all about. Now, the Lemieux reagent is actually called the Johnson Lemieux reagent after the person that discovered it, the Johnson Lemieux reagent. Now, what is the reagent? What is the Lemieux reagent all about? Now, the Lemieux reagent particularly is a mixture of perodate and osmium tetraoxide. It's a dilute solution of perodate and osmium tetraoxide. That is what the Lemieux reagent is. But in some of the reaction, KMnO4 is added to aid in further oxidation of the product that will be formed. So we can say that the Lemieux reagent is a combination of the perodate, which we can call the sodium perodate, something like this, and osmium tetraoxide. So you may be asked, what is the Lemieux reagent? You say the sodium, a dilute solution of sodium iodate and osmium tetraoxide, or a catalytic amount. Now, you say in these reactions, the olefins are oxidized to cis-diol, which is cleaved by the perodate to give aldehyde and ketone. If permanganate is present, it oxidizes the aldehyde further to carboxylic acid. Now, what is the reaction all about? This is an alkene, right? Now, when this alkene actually reacts with the Lemieux reagent, first of all, it will form a cis-diol. Now, what will be the product here? First of all, we said it will react to form a cis-diol. So we are going to have a cis-diol here. So the cis-diol will be something like this. H3C, like this structure. First of all, we have to map it out. Then we have CH3. Here is, of course, please allow me right here. Here is CH3. And then we are going to have the OH. Of course, you know, when this compound reacts, the OH should be added to the double bond of the alkene, the two double bond of the alkene. And since it is cis, it will go in one direction. So we have OH here and then OH here. So this will be the cis-diol. Now, this cis-diol will react with the perodate. It is the perodate, sodium perodate, that will cleave the cis-diol to give us the corresponding carbonyl compound, which can either be an aldehyde or a ketone. So when this one cleaves, look at this very well. If it cleaves and oxidizes, what do you think we are going to form? First of all, this will form what kind of alcohol to start with, because it is the alcohol that will be formed that will be oxidized further to give us the carboxylic acid. So what kind of alcohol do you think this will form? From the look of things here, this particular one is an alkyl group and this is an alkyl group, and then you have the OH. Now, the alcohol that has two alkyl groups surrounding it, we say that alcohol is called a secondary alcohol. So this part will form a secondary alcohol. Now, when secondary alcohols are oxidized, what are we expecting? When secondary alcohols are oxidized, according to everything we've learned, you are expected to have a ketone. So this product will give us a ketone. So this will give us something like this. Come on. Thought this was, black. So we have H3C. And then you have double bond O, CH3. Now this is the product that is formed. This is the ketone product that is formed. Plus, now how about the second one? What is it going to give to us? Now, from what you see in this second one here, of course, for the reaction to complete the valency, or for the valency of carbon to be complete here, we need to add one hydrogen. Now, if you add hydrogen to this place, or let's add it here. Now, if you add hydrogen here, what do you see here? It means that you have arrow, because this is an alkyl group, which you can represent as arrow. Then you have CH, right, which is this hydrogen. And then you have OH. Now, what kind of alcohol is this? This alcohol that have only one alkyl group attached to the carbon carrying the functional group. What do we call this? We said this is a primary alcohol, or a 1 degree alcohol. So this 1 degree alcohol now will be converted to the corresponding carbonyl compound. So when alcohols are oxidized, what are we expected to form? We are expected to form the aldehyde, which is going to give us something like this. But in this case now, you have CH3CHO. CHO in the sense that you have the CH3 here. This place here is a carbon, right? We say oxidation means removal of what? Hydrogen. So if you remove the hydrogen from here, you have what? CHO. So you have CH3CHO, and this is an aldehyde. Now, what kind of aldehyde is this? You call this acetaldehyde. And then what kind of ketone is this? This one, they have 1, 2 acetyl. So this one is also acetone. For the fact that it has 3 carbon does not make it another. It's called acetone also, or you can call it propan-2-one. So that is the product of this reaction. Now, at this our level, we should have known how to at least name compounds like this when we see them, right? This is acetone, and that is acetaldehyde. Now, this is an aldehyde, while this is a ketone. Now, ketones are not easily oxidized, but aldehyde are oxidized to give us the corresponding carboxylic acid. So that's the function of KMnO4. So KMnO4 will react in this reaction to form the corresponding carboxylic acid. So when we react this with KMnO4, which is the potassium permanganate that is present there, it will oxidize this acetaldehyde to carboxylic acid. So this is going to give us acetic acid, because this is acetaldehyde. When it becomes oxidized, it gives us acetic acid. And that is the product of that reaction. It's quite easy, right? So I can come here and say this is acetic acid. So that's everything you need to know about the Lemieux reagent. It's a dilute solution of the perodate, sodium perodate, and osmium tetraoxide, called after Johnson Lemieux, not John Lemieux, Johnson Lemieux, who is the founder of the reagent, right? And sometimes it contains KMnO4, which will later oxidize the carbonyl compound that is formed if it is an aldehyde to a corresponding carboxylic acid. Now note that acetone is not oxidized. Do you know why? Because acetone is a ketone, and we say ketones are not easily oxidized to carboxylic acid. They are not easily oxidized, except in some cases where they are oxidized to give us esters, right? But for this case, we don't say they are what? Oxidized. So that's the product of this reaction, and that's everything you need to know about Lemieux reagent. So Lemieux reagent goes from an alkene, if you want to summarize it, from alkene to a diol, from a diol to an acetone, from the diol to the corresponding carbonyl compound, which may later be oxidized to the acid. Everything about the Lemieux reagent is this. So if you are asked, what is the Lemieux reagent? Now, this thing you see here is what is called the Lemieux reagent. Sodium perodate and osmium tetraoxide is what is called the Lemieux reagent. Now let us look at the next. The next is oxidation of aromatic ring. Now, bicyclic aromatic ring can be oxidized to dicarboxylic acid. At this point in time, I would still assume that we have known what aromatic ring is by now. We dealt with aromatic compounds in year 1, aromatic compounds in year 2. So by now we should know what aromatic compounds are, right? Now, aromatic compounds, you know, the pioneer of all aromatic compounds is benzene structure. However, when you react benzene with oxidizing agent, it is not oxidized. So benzene is not oxidized. And that is the reason why benzene is often employed as a solvent in organic synthesis, because you cannot oxidize it. Hence, it does not take part in most of these reactions. It's inert to oxidation reaction, right? So when benzene undergo oxidation, no reaction, right? But when bicyclic aromatic ring, that means aromatic ring that has more than one cyclic structure, like this is naphthalene, right? When they undergo oxidation reaction, this ring here cleave to form the corresponding carbonyl compound. So it cleaves to form the corresponding carbonyl compound, which is later oxidized to the carboxylic acid. So as this one is now, if you oxidize it, what we are going to form is a phthalic acid. This naphthalene, it forms a phthalic acid. And the structure of phthalic acid is something like this, right? This double bond, double bond, double bond. And then double bond oxygen, OH. This OH, this double bond oxygen. Now this structure is what is called, or let's, this double bond here, O. So this is what is called phthalic acid, right? So whenever these aromatic rings are oxidized, it forms, or phthalic acid. It's supposed to be something like this. So whenever this bicyclic means it has two cyclic structure. This is cyclic structure 1, this is cyclic structure 2. When they combine together, you call them bicyclic. React with ozone. You know ozone is an oxidizing agent through ozonolysis. It breaks the ring and then it gives the acid of it, which in this case is phthalic acid. Now when this compound reacts, what is the name of this compound? Can you actually predict the name? This is the structure of quinoline, right? Now when it undergoes the oxidation reaction with KMNO4, you know KMNO4 is an agent that also causes oxidative cleavage. So it breaks the ring and they will form a similar structure like this. But in this case, what will happen is, for this reaction to take place, it will not cleave this part of this group here. It will cleave this part here. Are you getting it? So it will lead to inversion of this configuration. Means in most cases, what will usually happen, there will be resonance in such a way that it will not cleave this part. When you say anything like, just know that you invert it. So if you invert it, the reaction will occur in this part, and then you have this structure. Here's my white pen. So you have this structure. Right? Then this, and then you have the nitrogen here. Then you have this and this. I think there's no space to write this. This double bond O, and this is OH. This double bond O, and this is OH. And this is what it will always form. Now, this place here can be decarboxylated. When you say decarboxylated, it means you remove what? CO2. It can be what? Decarboxylated. Removal of CO2. So if it is decarboxylated, what are you expected to form? It means we remove one carboxylic group from here, right? If you remove one carboxylic group from here, it's going to form this structure. Let me bring it up so that we can have space. This is something like this. Double bond, this, OH, double bond oxygen. And this is what is called nicotinic acid. Now, in pharmacology, we'll come across this nicotinic acid later in pharmacology. Are you hearing it? So just know that whenever these rings break down, it forms something like this. You know, O3 will form a process of ozonolysis. That is what happens here. KMNO4 will form oxidative cleavage. We did something like this before, right? And so on and so forth. Now, how about if you react this with chromic acid? Chromic acid now, which is we call it chromium trioxide in acetic acid. Chromium trioxide in acetic acid. Can we still remember what happened in this case? Chromium trioxide in acetic acid. Now we said that when chromium trioxide in acetic acid reacts with cycloalkene ring, it's going to form a carbonyl compound. True or false? It's true. If we can still remember what we did initially here, when we said if something like this react, let's say you have something like this, react with chromium trioxide in acetic acid in water, H2O. we said it's going to form a varieties of products. If we can still remember that one of the products will be alpha beta ketone. Are you getting it now? Or it's not alpha beta ketone. Alpha beta unsaturated carbonyl compound. Can we remember where we said it will also form cyclohexanol, cyclohexadiol, etc. That is going to form a majority, is going to form a varieties of products rather. Same thing is applicable here. So when this acetic acid in chromium trioxide, same reaction is going to take place. That is going to form alpha beta unsaturated ketones or unsaturated carbonyl compound. In this case is ketone anyway. So this product will be something like this. But you need to take note that there are two alkene here. When we did it here, it was only not alkene naturally. There are two unsaturated group here, which is two double bond here in this case. Why here is one? Now when we use one, it forms this product. So if we use two, it's going to form what? Two double bond oxygen, which is two unsaturated or diketone rather. So this is going to form something like this. This, and then you are going to find something like this, right? Double bond, then we'll have double bond oxygen, double bond oxygen. This will be the product of the reaction. Now what is this? This is naphthalene. And then this will be naphtha or naphthoquinone. You should take note of this. Now, another thing again that I want you to recall, we said that when naphthalene reacts with KMNO4 or react with ozone, it cleaves it to form phthalic acid. But when it reacts with chromium oxide in acetic acid or chromium trioxide in acetic acid, it forms let's say alpha unsaturated or alpha beta unsaturated ketone, but in this case to be alpha beta unsaturated diketone, because naphthalene has two double bonds. If it were to be one double bond, it become alpha beta unsaturated ketone. As in the case of this, I actually elaborated on this in one of the lectures where we had something like this, alkene, right? Plus, if you can still remember, OH plus CrO3. This gave us something like this. Where I said is one of the method of converting alkenes to alpha beta unsaturated compound, and also this will also form adipic acid. Can you remember now? Where we said there will be cleavage of the bond to form adipic acid, right? So the same thing is what we are doing here. So that is basically that for this question, right? And that will be that for this lecture. It's a very short and simple lecture. That whenever these bicyclic aromatic ring are oxidized, the ring cleaves to form the carboxylic acid or the dicarboxylic acid. Say bicyclic ring can be oxidized to dicarboxylic acid. It can also be oxidized to quinone. So if you are asked why what can bicyclic ring be oxidized to, you say it is either they can be oxidized to dicarboxylic acid or they can be oxidized to quinone, right? But benzene is resistant. So whenever they say benzene reacts with any oxidizing agent, know that there is no reaction. But this one will react to form a dicarboxylic acid. Now, why do we call this a dicarboxylic acid? Because it has two carboxylic acid group. This is one carboxylic acid group and this is another. And we say this compound is called phthalic acid. This same one, dicarboxylic acid, which we said will be decarboxylated to form nicotinic acid, which you are going to come across in pharmacology later, right? And then finally, this other one here, we said it can either form a dicarboxylic acid or a quinone. So it is when it reacts with chromium trioxide in acetic acid that the product is a quinone, right? Which we can say is alpha beta unsaturated diketone. That is what this product will form. And we actually got our answers from from understanding this particular one that we've done before. Thank you very much for your time. Bye bye. We'll see you in the next lecture.